Lesson 7.3 notes on solving equations using multiplication and division. The key idea is that we're going to use the multiplication property of equality. We have already looked at the addition property of equality and the subtraction property of equality. The multiplication property of equality says that when you multiply each side of an equation by the same non-zero number, then the two sides remain equal. So the way that looks with numbers, if we have 8 over 4 equals 2, you know that 8 divided by 4 is equal to 2. If I multiply the left side by 4, and I also multiply the right side times 4, I know that if I multiply here, I could cross cancel. I could have a 4 there and a 4 there, and so that would leave me with 8. And 2 times 4 is also 8. So when I multiply both sides by the same number, it stays the same. With algebra, doing the same thing. Now we've got an x in the numerator, but I'm going to multiply by whatever was in the denominator so that I can make that cancel out. And then that leaves me with an x in the numerator. And whatever I did to one side, I have to do the same thing to the other side, and it equals 8 on that side. So whatever I do to one side, I do to the other side, and the sides remain equal. Okay. Then there's this big idea. So this is a long word and a really important idea. This is multiplicative inverse. I'm going to write that a little simpler. This is like multiplying by the reciprocal. Okay, it's the idea that when you multiply by a reciprocal, your answer is equal to 1. All right, so what that looks like in math language, the product, when I multiply any non-zero number, n, and its reciprocal, so that's 1 over n, then I get an answer of 1. What that looks like with numbers, we did this with numbers. You've got 5 times, and then you flip that, so 5 times 1/5. Well, 1/5 of 5, that's 1. The 5 here, it's like you write it over 1, like a whole number written over 1, and then the 5s cancel out, and you're left with 1. But where we're going is using it to solve algebraic equations. So n times n minus 1, that equals 1. But n cannot equal 0. You can't ever have a 0 in a denominator. Okay, so let's look at using those properties to solve some equations. So my equation is w over 4 is equal to 12. Well, I know that this means w divided by 4. So the opposite of dividing is multiplying. So I'm going to multiply both sides by that reciprocal so that I can make the 4s cancel out. So I'm going to bring that down. And on this side, I'm going to multiply by 4. And on the right-hand side, I'm going to divide by 4. Do you remember the dot, dot, dots? I'm going to put the dot down through the middle. So whatever you do to the left-hand side, you do the same thing to the right. Right? You find the variable, find the side with the variable. Ask yourself, what is being done to the variable? This variable is being divided by 4. So to undo that, the inverse of that is to multiply by 4. Whatever I do to one side, I have to do the same thing to the other side. Now this 4 and this 4 cancel out because they are reciprocals. I've got a 4, and this is 1 over 4, so those cancel out. And I'm left with w equals 12 times 4 is 48, right? The way I check it is by substituting 48 back in for w. So I've got my original problem was w over 4 equals 12. I'm going to substitute 48 in for w. If I do 48 divided by 4, does that equal 12? Yes, it does. So that is a solution, right? That tells us if the answer is correct. When I am asking you to verify your solution with substitution, this is what I mean. Take the answer that you get and substitute it back in and make sure that it gives you the expected answer. If it doesn't give you the right answer, then you know you've made a mistake. Okay, here's the kind of problem that kids have the most trouble with. Okay, because this one's pretty intuitive. I'm dividing by 4, so I'm going to multiply by 4 to undo that. But if I have a fraction 2/7 x equals 6, then the way I undo that is by multiply by the reciprocal. Or multiply by 7 over 2, put my dot, 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 and whatever I do to one side, I have to do the same thing to the other side. Write the multiply by the reciprocal. Tattoo that on your arm or write it in permanent marker. Multiply by reciprocal. That's how you undo. So now the 7s cancel out and the 1s cancel out, or so 2s cancel out to leave us with 1. Isn't that what the multiplicative inverse property said? If I multiply by the reciprocal, then all this stuff cancels out and I'm left with just x. And then sometimes when I'm working with a fraction, lots of times I go ahead and put it over 1 just to help me kind of as a placeholder, keep track. I multiply the numerators. 6 times 7 is 42. Multiply the denominators. 1 times 2 is 2. But you have to simplify. 42 divided by 2 is 21. All right, and then we're going to check, take your original problem, which was 2/7 x equal to 6. All right, so let's substitute 21 in for x. So we're going to do 2/7. If there's no operation, remember that means times. Put in a 21 for the x. I'm going to put it over 1 so that I can work with the fraction equal to 6. Let's see, 2 times 21, that's 42. 7 times 1 is 7. Is 42 divided by 7 equal to 6? Yes, it is. So check your answer by taking the value that you get for x and substitute it back in and make sure that it gives you that expected answer. If it doesn't, then you need to go back and check your math. Okay, you have 3 U tries. Remember to multiply by the reciprocal. I'm going to help you set this one up a little bit because kids always have trouble with this. So this is 3z divided by 2 equals 9. And I can change that and I can just write that as 3 over 2z. Okay, now does it look like a problem you're used to? It looks like this problem now, right? Did I tell you anything else about that? I think it's okay there. Okay. So then continuing on that idea, we can also solve algebraic equations using division. So the division property of equality, it's just like the multiplication property. It just says that when you divide both sides of an equation by the same number, then the two sides remain equal. So this time I have 8 times 4 equals 32. Well, to undo that, I'm going to divide both sides by 4, and then I'm left with 8 equals 8. If I'm looking at that algebraically, that says 4 times x is 32. Well, the opposite of multiplying by 4 is dividing by 4. So I'm going to put divided by 4, and I get x equals 8. These 4's cancel out, which leaves me with x, and 32 divided by 4 is 8. If you write it with a division sign instead of the fraction, I'll still count that correct, but this is what you need to be moving toward, all right? In algebra, we write our division as a fraction. All right, so let's look at that. Look at some examples. I've got 5b equals 65. Find the variable. That's a b, not a 6. This says 5 times b, so the opposite of multiplying is dividing. So I'm going to divide that by 5. And remember, whatever you do to one side, you have to do the same thing to the other side. And now the 5 in the numerator and the 5 in the denominator cancel out to make 1, leaving me with b. And 65 divided by 5 is 13. And then I check to make sure that's right by substituting 13 in for b. So let's do 5 times 13. You can use the dot. You can use parentheses. Please do not use an X anymore, right? Because now we're doing algebra and the X and the times sign will get confused. 5 times 13 equals 65. Is that true? Yes, it is a solution. It is the solution, right? And you have 3 problems and they're very similar. There's a dot between there to show you its multiplication. And here you have the variable on the right-hand side, but you work it exactly the same way. Find the variable, whatever's with the variable, undo that. Okay, and then our little real-life-ish application. We've got a parallelogram here. I believe in the last set of notes, we talked about the area of a parallelogram is equal to its base times its height, because it's like a squished rectangle. All right, this is like a squished rectangle. So this is the base. And then the height is not the length of the side here. It has to be the height, like from the bottom to the side. I don't remember if you remember from last year how it has a right angle. So it has to, the base has to make a right angle. All right. This is the height has to make a right angle. Okay. And so it tells us that the area of this parallelogram shaped courtyard is 2,730 square feet. And they want us to find the length. Oops, I should have written it as, let me change that. They're giving it to us as length times width instead of base times height. That's a little confusing. Sorry, we'll use the same language that we use with a rectangle. So this is going to be the length, and this is going to be the width. I really like base and height better. Oh my gosh. I've messed up again. Look, they want the length to be the sidewalk. All right, I'm going to fix it one more time. Sorry, people. Let's go back to the original way. I still like base times height better. Sorry, I made you mess up your notes. Okay, this is still base because that really fits our picture better. And this is the height. But the thing that we're looking for, the length, that's going to be the same thing as the height. All right, now let's substitute in. So when I am solving an equation and I'm using a formula, something like area equals or perimeter equals, I write down the formula first. I always do that. And then I can substitute in the things that I know and solve for the thing that I want to find out. I can solve for the unknown. So my area is this. So let's substitute that in. 2730 equals the base I can see is 65. So I'm going to substitute that in there. And the height is the thing that I'm trying to find. Right? Let's make it a little bigger. Okay, so to solve for h, it's okay that it's over here on the right-hand side. This says 65 times h. So to undo that, I'm going to do the opposite of multiplying, which is dividing. divide both sides by 65. Whatever you do to one side, you have to do the same thing to the other side. Start a little dot, 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 so we can keep the sides of our equation separate. And then the 65 in the numerator and the 65 in the denominator cancel out. That's why you divided by 65, leaving you with the h. And then I'm going to grab my calculator, and I'm going to punch in 2,750 divided, 2,730 divided by 65 equals 42. And so the length of the sidewalk is 42. 42 what? Oh, if this is in square feet and this is also in feet, then this must be 42 feet. All right? And let's look at the you try. See, you and 4 friends. So if you and 4 friends are going together, how many people is that in all? Are buying tickets to a baseball, and the total is $70. Write and solve an equation to find the cost of each ticket. So you have to think first, I need something over here, and the answer is going to be 70, right? So we don't want to use a variable as the answer. I want the variable over here. Okay, make the variable be part of the problem. And let's see, what is the variable going to stand for? It's going to stand for the cost of the ticket.